Hi, my name is Rick Brown. I am a longtime science teacher and educator. My mission is to get students of all ages excited and interested about science. I want to help them become responsible citizens of the 21st century, capable of creative, independent thinking and problem solving, while promoting creativity, collaboration, and communication skills. I have a variety of programs that I have developed and performed over the past 10 years. The following video gives you highlights of my Meet Sir Isaac Newton show. In this performance, I show you the man behind the science and give live, interactive demonstrations of his contributions to science. Well, since I had to unload all this stuff out of the time machine and my assistant is actually working on the time machine, I've got all the stuff that we could talk about motion. And actually, I know a thing or two or three about the laws of motion. I was recently knighted by the Queen of England, Queen Anne, and now I get to call myself Sir Isaac Newton. At your service. Let's talk about the story of me and the apple. Does anybody know the story of me and the apple? The apple supposedly fell on my head.
And you wondered why it fell?
And I wondered why it fell. And that's a good story, although it didn't necessarily happen. When I was growing up, I was very observant. I've been observant my whole life. And when I saw things, I did something that this gentleman said, I wondered about it. So when I saw the apple fall, or I saw the pine cone, or whatever, or I saw the earth as it orbited around the sun, or the moon orbiting around the earth, I said, why does it do that? Why doesn't the apple fall up? And I started thinking about it. So when I was 16 and supposedly it fell on my head, when I was supposed to be doing work like maybe fencing in the pigs, I started thinking about it, but it was very much longer. It was almost 25 years later before I ever came up with those ideas well enough so that I could write them down, and they became the laws of motion and the theory of gravity. If I have seen farther, it is because I have been on the shoulder of giants. And that really means that I wasn't the first one that thought of a lot of these things. There were people before me. I made their ideas a little better or went a little farther with their ideas. And one such one was from a man that invented this. He called this an engine. What does an engine do? It makes things move. Makes things move. So I'm going to get a little bit of water out of this very strange container, and I'm going to put the water in here, maybe another squirt. And I'm going to add thermal energy. Do you know what I mean by the word thermal energy? Gases take up more space. As they take up more space, they've got to go somewhere, don't they? And you can see there's only two places that the gases can go, out the ends of the tube. And this is a steam engine. Maybe I've got a better one here. This is something I have just seen. I love these things. We didn't have them back in my time. These stretchy things. And they have a hole in them. And you can put air in them. Balloon. I think I've heard that. So, it's nothing special to you if you've seen a balloon already. I hadn't until about 2 weeks ago. If I let the air, if I just let this go and the air comes out this way, that's the action. Which way does the balloon go? But whatever way this air goes out, it's going to go the other way. Give me a push. All right, and I mean a push. I mean a real push. You got a football shirt on there, so I want a real hard push. Are you ready? Now, wait a minute. We just got done talking about the third law of motion that said, if he pushes me that way, what should he do?
Go that way.
He should go that way. Why didn't he? Did he break my law? What about his feet? Why are his feet so important? Friction. The friction between the bottom of his shoes and the floor is keeping him there. So let's get rid of the friction. Okay? How about that? Ready? Go ahead. Let's talk about that. Let me say that I give it a certain amount of push. All right? How far do you think it would go? Anybody got an idea? If I just give it a push. If I keep giving it more and more push, it's going to go past Virginia, maybe into the Atlantic Ocean, maybe if I push it far enough, it'll go all the way to my home country, England, maybe where I live in London. If I keep pushing harder and harder, it's going to go farther and farther. It's going to go past England, past Europe, past Asia, all the way past the Pacific Ocean, all the way into your western states, and finally it's going to end up where? It's going to end up right back here. And so we can make something orbit. So let's shoot a rocket off. And I'm going to go ahead and send it into orbit. You want more in? Okay. I squirted a little more in. Oh! And we said that there was two things that slow an object down, those outside forces that work on slowing and stopping things that are in motion. Can you name those two things again? One of them was? And the other one was? Friction. So, which one of those would be easier to get rid of here on Earth? Yes, sir? Friction. Because we're not going to leave Earth, are we? No. And Earth is causing the gravity. If I try to give her a push, I can do it, but it's not a whole lot. And you'll notice as soon as I stop pushing, then the force of friction and gravity stop the motion. Correct? All right. I'm going to do something, though. I am going to get the surfaces of those two objects, the floor and the disc, to be slightly apart from each other. Are you ready?
Yeah, sure.
You're not sure about that, are you? Does anybody know what's in this balloon? This is actually hydrogen. Hydrogen, on the other hand, is extremely friendly and will hook up with a lot of things. You know that hydrogen hooks up with oxygen to make water. That's just one of the things it does. So, even inside this balloon, the hydrogen are not by themselves. They are hooked to another hydrogen. So there's H2.